Hey guys, welcome to the notes for Arithmetic Sequences. We're in Unit 2. Our essential question is, how do I find the common difference? So, an arithmetic sequence is a certain or special type of sequence. So let's first talk about what a sequence is. And I apologize if there's any background noise, they're cleaning the floors right now. So, a sequence is a list of numbers. And lists of numbers are things that you've seen for a very long time. So, here's an example of a list of numbers. Okay, I have a list of numbers here, 2, 5, 8, and 11. Now, let's talk about what terms mean. Terms just mean, if I'm asking you for the fifth term, I want to know which one was fifth in the list. If I'm asking you for what the seventh term was, I want to know what the seventh one in the list was. So, if I ask you for the third term here, that's going to be number 8, because that's the third one in your sequence, or the third one in your list. The first term would be 2. The second term would be 5. The fourth term would be 11. So that part is hopefully pretty self-explanatory. It's just whatever order they're in. Now let's talk about what arithmetic means. So yes, it looks like arithmetic, but we pronounce it arithmetic. Arithmetic sequence. So an arithmetic sequence is a special type of sequence. And these sequences are sequences whose change is denoted by adding or subtracting. Okay, so an arithmetic sequence is a sequence where you're either adding something or subtracting something to get from number to number. The common difference is the number you're adding or subtracting. So this is the number I'm so sorry that the noise is getting louder. Adding, or subtracting. So let's look at the sequence we had earlier. 2, 5, 8, 11. Is this an arithmetic sequence? I'm going to say yes. And the reason why I say yes is because I'm constantly adding a number to get from term to term. I'm adding 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. So I'm adding 3 constantly. So here, yes, it's an arithmetic sequence. And the common difference would be positive 3 because I'm adding 3. So for example, if I have a sequence that's 30, 20, 10, 0, ... right? If it keeps going and going and going, well, this is also an arithmetic sequence because every single time I'm subtracting 10. So yes, arithmetic, my common difference is going to be negative 10 because I'm subtracting 10. Now, if I put a 1 here, now this is no longer arithmetic. I'm not subtracting or adding the same thing every time. Okay, so let's do recursive formula real quick. Now, recursive formula is just the way I defined this, and it looks really scary, but I promise it's not as scary as it looks. So the a of n part, so just like function notation, like f of x, we pronounce it the same way, a of n, this is going to be the term I am looking for, or the one that I am talking about, looking for. Okay, the second part, a of n minus 1, is the previous term, or the term that was right before the one I'm looking for. The last part here, the plus d, that value represents your common difference. So below I have an example, and we're not going to write all of our problems or solve any of our sequences this way, but I do want to kind of show you what this means. So here, what is the term that I'm looking for? Well, that's going to be this part in the front, and that's going to be my fifth term, because a of 5 means the fifth term. What would a of 3 mean? The third term. So we're looking for the fifth term. So we're going to use the value of whatever the fourth term was, your previous term, and then you add the common difference to it. So you take the fourth term, you're going to add something to it, and then you're going to get the fifth term from that. Does that make sense, hopefully? So for example, if I wanted to know what the fifth term here was, right, because I have the first, the second, the third, and the fourth, if I want to know what the fifth term was, I would take the previous term, which is 11, and then I would add 3 to it to get to the next one. So my next one would be 14. So you know how to do it in your head. This is just kind of a visual and formula that you're actually doing every single time you're doing that. Okay, so Determine if the following are arithmetic. If they are, find the recursive formula and the next 3 terms. Okay, so let's look at number 1. The first thing we're asked to find is if it's arithmetic or not. So I have 3, 6, 9, and 12. Is this arithmetic? Well, it's arithmetic if I'm adding or subtracting something constantly to get to term. And here I am. Each term I'm going to go and add 3, right? Every single time you're adding 3. So I would say yes, this is arithmetic. And my common difference would be 3. Let's go ahead and write a recursive formula for this. So every recursive formula starts the same. A of n equals A of n minus 1, just like the front page. But your common difference is going to be that thing that's changing. And the common difference here is going to be plus 3, because every single time I'm adding 3. Okay? So that's the first and second part. So you determined if it's arithmetic, so I said yes. And then it said find the recursive formula, which I did. This is the recursive formula. And then you're going to find the next 3 terms. Well, how many terms am I already given? I'm given 4 terms. So the next term would be the 5th term, so A of 5. Okay? Now, how do I get A of 5? Well, the last term I have is 12. So I'm going to do 12 plus 3 to get 15 to get the next term. Okay? Then I'm going to find the next term, which is the 6th term, A of 6. Remember, that means the 6th term. To get the 6th term, I'm going to take the last term, which was 15, and add 3 to that. That's going to give me 18. And then the next thing I'm going to have is for the 7th term. And I'm going to take 18 and add 3 to that and get 21. So these are my 3 following terms. Why did I find 3? Well, it's because I was asked to find 3. So if I was asked to find 5, then I would find 5 more terms. So again, the thing you're going to do is determine if it's arithmetic, give me the formula, and then do the next 3 terms. So let's try that for the next one. 8, 5, 1, and negative 7. What do you notice here? Well, if I go from 8 to 5, I'm subtracting 3. But if I go from 5 to 1, I'm subtracting 4. So is that consistent? No. So this is not arithmetic. If it's not arithmetic, then I move on, and I leave it alone. All right, number 3. Negative 5, negative 3, negative 1, 1. So let's see how we're getting from term to term here. Well, from negative 5 to negative 3, I'm adding 2. From negative 3 to negative 1, I'm adding 2. From negative 1 to 1, I add 2. So each time it's going up by positive 2. So I would say, yes, this is arithmetic, and my common difference here is going to be positive 2. Okay, now I know the last 2 examples we've had, they're adding. But again, you could always have something that's subtracting. So you could have minus 5. So if it's minusing 5 each time, your common difference would be negative 5. Okay, the next part is I want to find the formula, the recursive formula. Again, they always start off the same. A of n equals A of n minus 1. Now your common difference here is plus 2 because you're adding 2 each time. Then you're going to find the next 3 terms. So since I already have 4 terms, the next term is going to be the 5th term. Now the last term I had was a 1. And so I'm going to take 1 and add 2 and get 3 for that. The 6th term will be 7, and the 7th term will be 10. Because the 7th, well, none of those were making sense. 3, and then 5, and then 7. I'm so sorry. I was having a big brain fart. Okay, so you're adding 2 each time. So 3 plus 2 is 5, 5 plus 2 is 7. Okay, moving on. We have 24, 28, 32, 36. This is also arithmetic because each time you're adding 4. So this is, yes, arithmetic. My common difference is positive 4. So my formula is going to be A of n equals A of n minus 1. And then I would have plus 4. So then I would have A of 5 equals 40 here. A of 6 would be 44. A of 7 would be 48. Now remember, I have A of 5, A of 6, and A of 7 because those are the next 3 terms because I'm already given the first 4, so I need to find 5, 6, 7. Okay, the last problem is saying if A of 1 equals 7, and the recursive formula is A of n equals A of n minus 1 plus 4, find the next 3 terms. So first, let's talk about what A of 1 equals 7 mean. Well, A of 1 means first term. And if it's A of 1 equals 7, it's saying that 7 is the first term in our list, the first term in our sequence. Then it wants us to find how many terms. the next three terms. So the next three terms will be finding a of 2, a of 3, and a of 4. Those are the next three, okay, because they follow the first. Now, how do you get from term to term? Well, it says I'm going to add 4. That's really the only part that's really important to me is this this back part, which says add 4. So 7 plus 4 gives me 11. 11 plus 4 gives me 15. And then 15 plus 4 is 19. And that's all I have to do. So you just basically have to understand what function notation means and what the sequence wants you to do. If you have any questions, please feel free to come in and ask.